Hey, I'm gonna go over station 4. Oh my gosh, station 5. And I have all the writing here, and I'm just gonna talk about it. Okay. The manager of a children's puppet theater has determined adult tickets. He's going to call that variable X. Adult number of adult tickets he sells is variable X. So I just said X is adult tickets. I just wrote it out explicitly. And Y is the number of children tickets. So the first one is, gives mean and standard deviation of the number. Okay. So we want to then define a random variable. A is the money he collects on the adults. Well, if the adult tickets are $10 each, then A is just going to be 10 times X. And to find the mean of A, you just multiply 10 times the mean of X. So you're going to make, on average, $283 on adult tickets. And the standard deviation, you just multiply also that by 10. So, because 5.3 tickets equates to $53, right? Because $10 a ticket. So when you're multiplying by a constant, the mean and the standard deviation also get multiplied by that constant. Okay, so that's what happens there. Now here we're doing like a combination of multiplying one of the random variables by a constant, and then we're combining. So something, two things are at play here. So here now we're defining a random variable T as the total amount he collects on all the ticket sales. Well, we've already identified the amount he has collected on adult tickets, which is A. You could also call that 10x, but we already found it, so why not just call it A? Now, we haven't defined a random variable for the amount he's made on children, but I can just call it 6y. But then I have to do a little bit. I'm basically having to do two things because I already did that step to find the amount he's making on adult children up here. And I haven't done on adult children on adult tickets up here. So let's look at what we're doing here. To find the mean of the amount he makes on the total, I need to take the mean of the amount he makes on the adult tickets, which is 283, plus the mean that he's going to make on the children tickets, but I still have to calculate that. So I'm going to, instead of like defining another random variable as, something else, I'm just going to say 6y, right? Because I do know the mean of the number of tickets he sells to kids, and it's $6 per ticket. And I know that just then you multiply the mean of the number of tickets by 6 to get the mean of the amount of money he'll make on children tickets. So I took the mean of the amount he makes on adults plus the mean of the amount he's going to make on the kids, which will be 6 times the number of tickets, the mean of tickets sold to kids. And then I did some math and I got $538. Okay, so the mean total amount on tickets. Now, the reason why we have this weird standard deviation formula is because when you're combining random variables, you do not add them. Okay, you take their variances, which is the standard deviation squared, add them, and then take the square root to get the standard deviation. So basically, you're adding their variances, taking the square root. Okay, so the standard deviation of the amount that you're making on adults is $53. Okay. Now, we had never calculated the standard deviation for the amount you're making on kids, which needed to be 6 times the standard deviation of the number of kids. So 6 times 8.1. We hadn't done that calculation for kids yet. Then square that. Okay. Add it to that. Take the square root. So 71.9. So on average, let's see what T represents. The total number he collects for all ticket sales will vary from the mean by $71.90. Okay. So now we're going to talk about his profit. So it looks like he spends $300 on the shows. And so the profit is, we've already done total revenue, thank goodness. And all we're going to do is subtract 300. We need to remember here that we're just subtracting a constant. Okay. So we're not combining two random variables. We're just subtracting a constant. When you subtract a constant, the mean stays the mean also gets subtracted by that constant. but the standard deviation doesn't. It stays where it's at. Okay. Okay. So we have the mean of his profit is going to be, on average, he's making $538 in revenue. We're just going to subtract 300 his cost. That makes sense. His mean profit is 238. But the standard deviation doesn't change, right? Because that $300 doesn't get multiplied, or it doesn't get subtracted. So the standard deviation, give or take, $71.90. Yes. All right. Hope that helps. I would say, ask yourself, there's different rules for if you're multiplying of mean and standard deviation by a constant versus combining, adding. And sometimes you're doing both, like here. So you need to keep those rules separate. And we did them 2 days in a row. Maybe not 2 days in a row. The notes were in a row. Transforming variables was just this, but that is different than combining. And combining is where we had these awesome variables and these equations here. Okay. And that's where those weird standard deviation formulas come. Right. Stop sharing.